when people spin glow props in like the real world and you sort of watch them, the light from the glow props leaves like a bright spot in your eye, so you end up with this effect of a trail where you can see places the glow prop has been before, which creates like this nice neat effect where you can sort of see like arcs of circles and whatever else. Unfortunately, if you try to record it, as we are now, you only get the bright light because cameras don't sort of have this failure of the eye that makes this look prettier. So to address this, we created our project where pretty much we tried putting these trails back in and even putting them in more than your eye will see. And so here you can see that like behind the prop there's this trail creating these nice arcs, and you get to see this effect in real time, which means that like as you're spinning or practicing, you can use this to either like improve because you can know what path you followed, or just to make pretty lights and be happy.
So to create this effect, we use an algorithm that we designed ourselves based on an infinite impulse response, or an IIR filter. Essentially what it's doing is picking out the brightest pixels in the frame, which are most likely to be part of the prop, which we calculate by calculating the luminance out of the RGB values that are coming in raw from the camera. And if it's bright enough, then over the course of time, those pixels will maintain their value, and each new pixel is determined by the input from the camera and the previous frame. So bright pixels from the previous frame are likely to stick around with a slightly decayed value, and pixels that are less bright will end up getting replaced with the new camera input. So through this, the performer will stay as a single image, while the prop will have its image copied over several previous frames, and you display the glow trail like this. You can adjust the threshold to see the props in different lighting conditions, and the decay value is set currently to 98%, but it can be set to different values to change the length of trails.
For this, we're using the same VRAM that we used in lab. We're storing RGB 565 images at 240p, and pretty much we need a read and a write for the IIR algorithm, and we also need a read for the HDMI output that we can see. So we had to write some sort of interface because the VRAM can only take one of those.
So for this project, we're using the OV5640 camera. It's not the same camera that we used in lab. So we needed to be able to set all the settings on it, which we do using the same microcontroller as in lab. It communicates over I2C, and it sets a sequence of registers so that the camera knows what type of output we want to get from it. The camera is capable of generating 240p video at 120 frames per second, or 720p video at 60 frames per second. Here you're seeing the 120 frames per second 240p video. We wrote modules so that we could interpret the data that is coming in the format that this camera gives it to us, and cross over into the clock domain of our algorithms.
For this, we're running 240p instead of 720p because of memory constraints, because we can't fit 720p into the VRAM memory. In order to be able to use the 720p image, we would need to use DDR3, which we didn't manage to get working in time for the end of the project. Some props have LEDs that turn on and off to create really neat patterns, which you can see captured here.